Marita, Rahman, and Hamza. So in the previous class, we discussed about the chemical equilibrium, some topics of the chemical equilibrium, and I have given some questions. Please do solve it. Very good, Marita. So I think it's very easy. You can see Kp is not equals to Kc. So we had a relation Kp is equal to Kc RT raised to the power delta Ng. You just need to look for delta Ng, which is not equals to 0. And you know that very good, Adrian. Delta Ng is equal to number of moles of the product in gaseous state minus number of moles of reactant in gaseous state. Oh, wait a minute. Will it be A or something else? Yeah, it will be. So if you are going to apply this delta Ng, what is the number of moles of the product in gaseous state? You can see 2 minus, you can see you are going to leave this because this is in solid state. So you are going to solve it. You will be getting 1 here. And if you are going to check this delta Ng will be equals to 0. And here 2 and 2, this will also be equals to 0. So the answer is A. Very good. Can we know answers from you, Rehan? Hamza? Okay, can I change the slide? Okay,
Yes,
moving to the next question. This is also from PYQ, that is the value of Kc is 64 at 800 Kelvin for this reaction. And you need to calculate the value of Kc for the following reaction. Please do it. Okay, I'll check it, MJ. D. Everyone is getting D. That means it may be correct. So let's see what is the answer. Yeah, it will be D. If anyone have any doubt, just ask me. You can see N2 plus 3H2, that is giving you 2NH3, and we need to calculate the value of Kc for this. You can see NH3 on the right hand side and here it is on the left hand side. If you just reversed it, that means you are going to reverse this first. And if you will see, there is 3H2 and here it is 3 by 2H2. Here it is 2NH3 and here 1NH3. That means it is multiplied by half. So you are going to take the power, whatever is the number, you need to take that in power, and it will, the answer will be 1 by 8. So these questions is quite easy that I have chosen for you. Next. MJ, any answer? KV, Rehan, Ashrit, Priya, Hamza, and Adria. Yeah, I will explain this. You just wait for a minute. Will it be B? Okay. See, as you can see that following reactions equilibrium constant are given. S in solid state. Yeah, it is. Option A is correct. S plus O2 that is giving you SO2 and it has K1 that is 10 raised to the power 52. Now 2S plus 3O2 that is giving you 2SO3 and its K2 is 129. Now equilibrium constant for the reaction, this what you have done here. As you can see, this reaction for which we need to calculate the value of Kc, this reaction comes with the combination of these two reactions. So what we did, what we do with this two reaction to get this, that is very important. Okay. So if you look at the reaction 2SO, where is 2SO? There is no 2SO. Wait a minute. 2SO, not 2SO, plus O2, that will give. Okay, let's start. 2SO3 is here, O2 is here, you can see 3O2 is here, and O2 is here. So how will you get? First, you need to multiply it by 2. First, you need to multiply it by 2. So I'm going to multiply this reaction with 2. So if you are going to multiply it by 2, is there any mistake in the question? Because this is your 2SO. Marita, how did you solve it?
So that's what I thought. Maybe this is a mistake in the question. SO2.
Can you repeat?
Sir, I think this should be SO2 in the question.
SO2. If I'm gonna write SO2, yeah, it will be SO2. There is misprint. Okay, it will be SO2. Because if there is 2SO, this reaction will not be balanced. And since it should be balanced, we are going to find the value of Kc. So as you can see, SO2 is here on the right hand side, and this is SO2 on the SO2 is on the left hand side, and this is SO2 on the right hand side. So I'm gonna just reverse it and multiply it by 2. So if you are going to reverse it and multiply it by 2, it will look like this. Now this reaction will have K1 or Kc, that will be, since we just reverse this, so it will be 10 raised to the 1 upon 10 raised to the power 52, and we multiply it by 2. So we are going to put the value on power 2. So it will be 1 upon 10 raised to the power 104. 104. Now you can see 2SO3 as it is on the right hand side. So you don't need to do anything. Just put 2S here and 3O2 here and write the reaction 2SO3, which has a value K2 has a value 10 raised to the power 129. Now you just need to add this two equation. You can see 2SO2. This 2S and 2S will be cancelled, and you can see 3O2 on the left hand side and 2O2 on the right hand side. So it will move on the left hand side, and you will have only O2. You will have only O2, and this what you will get 2SO3. 2SO3. So as I told you, when you are going to get a reaction, when you are going to calculate the value of Kc for a reaction which will come after the combination of two or more reaction, what you need to do, this K dash the equilibrium constant of this new reaction will be equal to K dash will be equal to K into K2, K into K2, and K has a value that is 1 upon 10 raised to the power 104 into K2 has a value 10 raised to the power 129. So you will be getting 10 raised to the power 25. That will be your answer. Okay, Adriel.
Yes, sir. I didn't understand because of the SO2 part. Question.
Yeah, there was a mistake. Can you change the slide? KV.
Yes, sir.
No discussion. This is also quite easy. So today we need to go through two chapters, ionic equilibrium, and I'm going to give an overview of this ionic equilibrium. And we will see, KV, you have sent the answer, that is, it is, wait, no, it's wrong. So it's so easy. Wait a minute, maybe it is correct. Should I check it? Why your answer is C? Yeah, it is C. So don't be confused after, no, not B. Adriel, you just calculated the value of delta Ng, which is equal to number of moles of the gaseous product 1 minus, and here the number of moles of gaseous reactant 3 by 2, which you will get minus half, and you know Kp is equal to Kc RT raised to the power delta Ng as a value minus half. But in here you can see the option is given in terms of Kp, not Kc. So if you are going to calculate the value of Kc, Kc will be equal to Kp upon RT raised to the power minus this. And if you are going to keep it in, move it in numerator, it will be RT raised to the power half. So your presence of mind will matter. Yeah, Adriel, that is good. Everyone done with this?
Yes, sir.
Now I'm going to give you an overview of this ionic equilibrium. Okay, is everyone aware of this Le-Chatelier's principle? Yes or no? Please do let me know. Rehan, Adriel, everyone aware of this Le-Chatelier's principle? No, sir. Okay, Astrid. See, Le-Chatelier's principle says that with any factor, if equilibrium is disturbed, if equilibrium is disturbed, then it will try to nullify the effect. Nullify the effect. All I want to say is that by any means of this effect, if we have a reaction which is in equilibrium, this is in equilibrium. So at equilibrium, we already discussed about the rate of the rate of concentration of product. The rate of reaction. The rate of backward reaction will be equal to rate of forward reaction, as well as we also discussed about the concentration of reactant and concentration of product become constant with respect to time. But let's say by any means you are going to add some concentration of A. Concentration of A, if you are going to increase, the equilibrium will shift itself towards right hand side to nullify the effect. If you are going to add concentration of D, that means directly you are increasing the concentration of B, concentration of product. So equilibrium will shift towards left to nullify the effect. And this is what Le-Chatelier's principle says. The equilibrium will shift in the direction to nullify the effect. Is that clear?
Yes, sir.
So this is what Le-Chatelier's principle says. This is very important. Now, about ionic equilibrium. First of all, acid-base theory. Acid-base theory. So I think everyone knows about this theory. And Bronsted-Lowry theory. Bronsted-Lowry acid-base theory. Then comes the most important, that is Lewis acid-base theory. AB theory, that means acid-base theory. So first of all, the main important we are going to discuss is about Lewis acid-base theory. Why it is so important? Because every acid does not contain H plus and OH minus. Initially, wait a minute. Let me discuss this first. What is Bronsted-Lowry acid-base theory? It says that the one which gives H plus will be acid, and the one which accepts H plus is base. But it is not necessary that every compound in this universe contains hydrogen, H plus, proton, or OH minus. So Lewis acid-base theory come into play, and it says that electron donor is the basic, the one which donates electron are basic, and electron acceptor, that is your acid. And this is almost applicable everywhere, and we also use this theory in organic chemistry. Okay. And there is another theory that is very important also, 1, 2. The zero number we are going to say is Arrhenius acid-base theory. Arrhenius AB theory, that means acid-base theory. And that says that the one which gives H plus is an acid, and the one which gives OH minus is base. Then after this theory comes Bronsted, and after Bronsted then comes Lewis acid-base theory. Is that clear? Please do let me know.
Yes, sir.
Also, it is very important to note that in this theory, Bronsted acid-base theory, proton donor, that means this is your H plus is basically proton. Proton donor is an acid. Okay, and proton, we can say proton acceptor is base. Now I'm going to give you the value of this pH. Everyone is aware of pH calculation, yes or no? pH has a formula, pH is equal to minus log of H plus, minus log of H plus. If you want to calculate pOH, pOH will be equal to minus log of OH minus. And also you should know pH plus pOH, this has a sum that is equal to 14. You are aware of this from class 10 pH scale, that is from 1 to 14. So this is pH plus pOH. It will be only equal to 14 at room temperature. If you are going to increase the value of the temperature, then this sum will also increase. This is very important. So if I'm going to give you, everyone is aware of the basic logs like log A raised to the power n to the base b. What will be the value of this? N log A to the base b, right?
Yes, sir.
And if you have log A into B to the base something C, it will be written as log A plus log B, right? And if it is written as log A upon B, that will be written as log A minus log B. If you have base C, it will be written. Is that clear?
Yes, sir.
Okay, so I'm gonna give you calculate pH of following. If I'm gonna give you directly, H plus has a concentration 10 raised to the power minus 5. And if I'm gonna give you HCl, wait a minute, H2SO4 has a concentration 10 raised to the power minus 2. So your date is not decided in the JEE paper. Just now.
So I got it today, sir.
Okay, what is the date?
So I got 8th April.
8th April. What about you, Adriel, Rehan, Marita?
Mine is on 6th, first day.
MJ?
I didn't get it yet, sir.
Please do write it and then let me know. Are you done with this? Oh. One is 5 and another is 0.7. Marita, any answer? 5 and 2. Okay, let me tell you about this. So this will have a formula pH is equal to minus log of H plus. So if you are going to calculate minus log of 10 raised to the power minus 5, this power will be directly come here. Negative into negative 4, positive, and log 10. Log 10 has a value 1. So the pH of the A will be equal to 5. But when we are going to talk about this H2SO4, so if H2SO4 has a concentration that is equal to 10 raised to the power minus 2m, so the concentration of H plus here will be 2 into 10 raised to the power minus 2m. Why it is so? Whenever you need to calculate the concentration of ions, you need to dissociate this H plus and SO4 minus 2, then balance it. Now it is balanced. Now you can see 1 mole of this will give you 2 mole of this. That's why 1 molarity of this will give you 2 molarity of this. Since we have a molarity of this as 10 raised to the power minus 2m, so 1 of 2, so we need to get this value. So this is the molarity or concentration of H plus in H2SO4, and then you are going to apply the formula pH is equal to minus log of H plus. H plus is 2 into 10 raised to the power minus 2. And as you can see, minus log of, we can write, I'm going to keep this outside of the bracket, log 2 plus log 10 raised to the power minus 2. And you can see log 2 has a value 0.30, right? Krishna?
Yes, sir.
So it will have a value minus 0.30, and this will come here. So it will be minus 2 log 10. So as you know that this log 10 will have a value 1. So this I'm going to multiply this. First of all, I'm going to write another line for this. It will be like this. And when you are going to multiply this negative sign, it will be negative and this will be in positive. So you will be getting 1.7, Krishna. Right?
Yes, sir.
So this will be the pH of the H2SO4 here. MJ, no answer?
Yes, I got it now.
Rehan, are you getting this? Priya, Astrid?
Yes, sir.
Okay. Can you change the slide?
Yes, sir.
Okay. Now the next question I'm going to give you is calculate. We need to calculate the value of POH. If the first one, the concentration of NaOH is given as 10 raised to the power minus 13m, and in the second one we have given that Just solve the first one. I'm just thinking about the question. Just do the first one. Adriel, have you got the answer? Thirteen. It will be. It's very easy. Very good, Ashrit. Now I'm gonna write some formula which is very important. First of all, there is a topic that is, are you aware of buffer solution? Yes or no? Buffer solution. See, buffer solution is a solution which resists the change in its pH by when you are going to mix a small amount of solvent, or when you are going to dilute an acid or base or a solution, then it will resist its change in pH. That type of solution is known as buffer solution, and it is of two types: acidic buffer and basic buffer. It is of two types: acidic buffer and basic buffer. In acidic buffer, you have to recognize whether which one is acidic or acidic buffer or basic buffer. Acidic buffer, that means weak acid plus salt of weak acid, this weak acid and a strong base. This is very important. Buffer solution is the solution which resists the pH, which resists the change in pH by diluting a small amount of solvent and all that. So it is of two types: acidic buffer and basic buffer. Focus on acidic buffer. What is acidic buffer? If the solution is of weak acid and the salt of this weak acid and a strong base. And basic buffer will be weak base plus salt of this weak base plus a strong acid. Are you getting my point, Krishna? So we can take an example: CH3COOH. It is an organic acid which is weak, and I'm going to write a salt CH3COONA. You can see this is a salt which comes from an acid CH3COOH, which is weak acid, and Na that represents a base which is a strong NaOH. If you are going to take an example of this weak base, that we can easily take the NH4Cl. Wait a minute. NH4OH. NH4OH is a weak base, and salt, that means you are going to take weak acid and a strong base. And you can see here the base is weak, which is NH4OH, and acid is strong. So this is the combination. You have to recognize whether which one is acidic buffer and basic buffer. Acidic buffer, that starts from acid, it will have weak acid, and a salt which contains this acid and a strong base. And basic buffer is the one which contains weak base. Weak base, as a strong base, you know, NaOH. Then you can take KOH. These are all a strong base. Then comes your COH whole twice, and all after this will be what we say weak base. These all are a strong base. And weak acid, you can take HCl, H2SO4, HI you can take, and then comes your HNO3, then comes your HClO4. After this, almost every acid that you will see will be weak acid. So you just need to remember the name of the strong acid, then you can easily do this. Is that clear?
Yes, sir.
Can I see the slide? Okay. Now there is a formula for both of this weak acid and weak base. Sorry, acidic buffer and basic buffer. The one is pH, that is equal to pKa plus log of salt upon acid. Salt upon acid. Okay, and this is known as Anderson equation. Anderson equation. Then comes your here POH will be equal to pKb plus log of salt upon base. This is for what? This is for basic buffer. Please do write it. I'm just giving you overview of almost every topic which are very important. Please do write it and then let me know. Are you done with this?
Yes, sir.
Yes, sir.
Okay. Then comes the topic that is solubility.
So S above in the above equation is strong acid, right? Strong acid and strong base.
Just wait a minute. I'm not able to hear you. Yeah. Now please speak.
Sir, what does S indicate in the above equation?
Anderson equation. Both are Anderson equation. Are you talking about the base one now?
Yes, sir.
That is Anderson equation. That is for basically buffer solution. Okay.
No, sir. The concentration of S is for.
S is for salt. S. Are
Okay.
you talking about this?
Yes, yes, I
Salt.
got it.
This is for salt. Oh, sorry, I forgot to write this. And you know, acidic buffer, this is concentration of acid, and this is concentration of base, right?
Yes.
Okay. Now come to the topic that is solubility. So AgCl, let's say it is dissociated into ions Ag plus plus Cl minus. And let's say its solubility is S and S. So if you are going to write the chemical equilibrium constant for this AgCl initially is in solid state, so we are not going to take this. Okay. Or you can write it like this. Wait a minute. You can justify it in the way. Just wait a minute. This is your AgCl. So it will be written as solubility. So molarity of Ag plus upon molarity of Cl minus. Okay. And then there will be molarity of AgCl. So you can write directly K equilibrium into AgCl. That will be equal to concentration of Ag plus is S into S. And you know that this AgCl into K equilibrium is basically solubility product, KSP. We say it is KSP. We say it is KSP. This is your solubility product. So in the most of the book or notes, if you look at it, it is directly written as like this: K equilibrium is equal to concentration of Ag plus into concentration of Cl minus, and then this is Ksp is equal to S into S, and then Ksp will be equal to S square. That is understood that this Ksp is equal to this and this, because this is also constant and this will be also constant. So we are going to represent with another constant, that is solubility product. Is that clear?
Yes, sir.
So you can easily calculate the solubility here. Solubility will be under root of Ks. Can I change the slide? I'm going to go for another type.
Yes, sir.
Now see, if the reaction is like this, CaOH whole twice, and if you are going to dissociate it, it will be Ca plus 2 OH minus. So what will happen here? You can see the solubility here will be S and here it will be 2S. Now, if you are going to calculate the Ksp, you know, concentration of Ca plus 2 will be here, and here it is concentration of OH minus, but here you can see the stoichiometric coefficient is 2. So you are going to put 2 here, and then you will be getting Ksp is equal to S into 2s whole square, because the concentration of OH minus is 2s, and here the power is 2 because of this stoichiometric coefficient. So this will be the answer. Ksp will be equal to 4s³ for this reaction. Now you are going to do for this. What will be the value of Ksp? I'm going to help you with this. Please do. Are you able to see that screen one note? Yes or no?
Yes, sir.
Very good, MJ. Okay, very good. Okay. So most of the topic or important topic from this chapter has been covered. Now I'm going to give you some important question from electrochemistry, and I hope that you can do it because you have studied it in class 12. The paper, the question is not that much tough. I'm going to show you some of the questions. Just wait a minute, please. So here you can go for the question. No, Riyaz, it's not 8s into 10 raised to the power 5. Just wait a minute, hold on a minute, everybody. Rehan, sorry. You can see there will be S and there will be 3s because of this stoichiometric coefficient. If you are going to write the value of Ksp, it will be concentration of Al plus 3 into concentration of Cl minus raised to the power 3 because of this now again. So here it will be S into, you can see 3s is there, which has a power 3. So 3 3s are 9 3s are 27. S cube into S is already there. So it will be multiplied and 27s. So this will be the Ksp value for this. Okay, Rehan. Please do this for me. I'm waiting. Will you be able to solve it? Yes or no?
Yes, sir.
Okay, please do it. Very good, Kelly. You can go for the question number second. Adrian, MJ, very good. Whoever not able to solve, that means you don't remember the formula. Hamza, should I explain?
Just a minute.
Adriel, Rehan, Ashrit. Okay, no problem. See. Okay, no problem, Adriel. You can send me message in chat box. Very good, Hamza. See, the conductivity of mercury at 0 degrees centigrade is given. The conductivity is given. Just wait a minute, KV, I will check it out. Okay, very good. Conductivity is given and the resistance of a cell is this. Then the cell constant of the cell is this. Cell constant. Cell constant that is represented by J star, you can say. So first of all, I'm going to apply this formula. R is equal to 1 by G. And from here, you can easily calculate the value of conductance G. G is conductance and G will be equal to 1 by R. And here, if you are going to solve it, I'm just going to use the calculator and you will be getting 4 point something, 4.11 or 4.1 ohm per meter. This will be your per ohm, not meter. This is your what? This is basically your cell conductance. This is your conductance. Now, kappa is equal to conductance into. Wait a minute. we can apply the formula of G star directly. Cell constant is equal to length of the conductor per unit area of the cross section, and G star will also have a formula that is equal to kappa upon conductance. So I'm gonna just equate this equation and you will get your answer. This two equation, kappa that is given as what? 1.07 into 10 raised to the power 6 Siemens per meter, and we just calculated the value of this, and you will be getting 4.1. So you will get 26 into 10 raised to the power 4. So here the x is 26. Okay, Rehan. Adriel. Okay, please do write it. And KV, you told me C is for 4. What does it mean? Just wait a minute. C is for 4. Very good. And D is for 1. D is molar conductivity. Very good. And A is for 3. Very good. Yeah, it is good. KV. Very good. Both of you are correct. So it's just the unit cell constant. This will go for, this is basically cell constant per meter. Molar conductivity, that will go for Siemens centimeter square per mole. And then this conductivity is basically per ohm per meter. And then degree of dissociation will go for, it is dimensionless, degree of dissociation of electrons. Okay, everyone. Just wait a minute, I'm gonna give you another question which is very easy, and it is based upon one of the most important topic from this chapter, and that is Faraday's law. Please do this. There is another question. Hold on a minute, I'll be coming in 1 minute. 5. Is it for question number 9?
Yes, sir.
No, it is not like that. What you have calculated? Quantity of electricity required. That means you are going to calculate the charge, not the mole. You calculated the mole, right?
Yes, sir.
To reduce 5 moles of MnO4 minus, that is already given. It cannot be 5. You can see Marita here. 1 mole of this required 5 farads, 5 farads. So 5 mole of this required 25, right?
Yes, sir.
So so the answer is 25. Yeah, it's real. Does anyone have any doubt in this? What about the question number 16? Very good. Priya, Hamza, it will be C. Does anyone have any doubt in this?
No, sir.
Okay.
So can you explain that? Question 16.
Yeah, C. Just wait a minute. I'll just explain it. The remaining people, please do this. Now I'm going to explain this. It's very easy. You can see which one will be equal to which. So I'm just going to take this. Lambda naught m NABR can be written as lambda naught m of Na plus. Wait a minute. Right in this. Yeah. Lambda Na plus, and it is m. For NABR, you are going to write in this way. And you are going to subtract minus lambda. Na plus is there. Na plus is there, and it is also M. And since minus is there, so I'm gonna put minus here as well. And this will be equal to M. So as you can see, if you are minus minus, so this will be cancelled, and only you have left lambda naught Br minus M minus lambda naught I minus M. We needed to calculate the incorrect one. And if you are going to do for the right hand side, you can see directly I'm going to write K plus, and this will be equal to Br minus, and minus it will be equal to lambda Na plus minus lambda naught Br minus. So you can see again, this was your LHS and this was your this is your RHS. Are they equal to each other? Not. That means this is the incorrect. If you are going to check all the three options in this way, you can see it's wrong. Or as you can see, NABR is here. If Na on the right hand side and Br on the K on the right hand side, left hand side, it will not be balanced. Here you can see KCl, NaCl, KBr, NABr. That means it is somehow it will be balanced KCl, and this is minus K will be cancelled by K, and Na will be cancelled by Na, like this. Okay.
Yes, sir.
You can put in this. So please go for question number 3. No, it's wrong answer. It will not be this much. If you are going to calculate lambda m is the value kappa upon C. You can see. Yeah, Adriel, that's good. 760 is the right answer. Don't be in a hurry. Just calm down and try to solve it. Everything will be all right. KV, have you got the answer?
Solving, sir.
Okay. Very good, Marita. Where you had mistaken.
It's a calculation mistake.
Yeah, okay. Just wait a minute. Everyone done with this? 7.6, how you are getting this 7.6? It's wrong. You just need to calculate the value of kappa with the help of this formula, cell constant upon R, and then apply the formula lambda m is equal to kappa upon C, concentration. And you will be getting, if you are going to do it correctly, you will be getting 760 Siemens centimeter square per mole. Rayon, very good. Okay, just wait a minute. Let me give some other questions from what we say. This ionic equilibrium. Okay, this is a good question. Okay. So I think this is our last class today, right? Officially. Just wait a minute. Let it. Yeah. This is a very good question. You can do it. Just wait a minute. Start. No. Wrong answer. Please use organic chemistry as well. Option C. Who said option C? Okay. Please use, as you can see, formic acid, that means HCOOH. acetic acid, that means CH3COOH, and then benzoic acid, that means PHCOCOOH. So decreasing order of electrical conductivity. You can relate this electrical conductivity with acidic strength. Acidic strength. That means basically if a substance which is more acidic than other substance, that means that substance will easily give H plus. That means it will ionize fast and it will conduct more. Are you getting my point, Krishna, Rehan, Adriel, Priya,
Yes.
Marita? So you can go
Yes.
for acidic strength and then you will get the answer. So with the acidic strength, if you are going for this is your A, this is your B, this is your C. So formic acid will be the most, then comes your benzoic acid, and then comes your acetic acid. Because in acetic acid, CH3 is there, which is decreasing acidic strength. In organic chemistry, we have studied this minus directly proportional to minus M and minus I, and inversely proportional to plus I and plus M. So due to this plus I effect, its acidic acidic strength decreases, and hence it is less acidic. So it will give a little bit H plus. Very good, Marita. Please do question number 6. This is a very good question that I'm gonna give you. Question 6, D. Rehan, very good. Everyone is done with question number D, yes or no? Sorry,
Yes, sir.
question number 6. So as you can see, which of the following are Lewis acid? Lewis acid are the one which attract electron, which gain electron, right? You can see pH3 is not an acid because pH3 is already satisfied with its lone pair. It has 8 electrons. BCl3 is an acid, but these pairs are not acid. pH3 again comes, SiCl4, both are not an acid. AlCl3, SiCl4. AlCl3 is an acid, but SiCl4 is not. BCl3 and LCl3, that's why D. Not B. KV. KV, are you getting my point? Yes or no?
Yes, sir. Yes, I got it.
Now come to this question, which is three reaction involving H2PO4 minus are given. Oh, can't we do this? Okay. Yeah, we can do this. So you can see in which of the above does H2PO4 minus acts as an acid? Option A, Marita.
Yes, sir.
First of all, the first will not be true because we are talking about H2PO4 minus and it is H3PO4. So we just need to think about this. And in the second H2PO4 minus, and this is your H2O, in which you can see H2PO4 is converted into HPO4 minus 2. That means it gave out H plus, and hence it is acting here as an acid. Is that clear? And
Yes,
here you can see H2PO4 minus. OH minus gives H plus, and hence it becomes H3. It accepted H plus. So it is not acting as an acid, it is acting as a base here, and hence the only answer is A. Is that clear, everyone? Okay. Everyone is aware of conjugate acid and conjugate base, right? Quite easy. You need to tell me conjugate base. Very good. How you get conjugate base? It's very easy. If you are going to remove H plus, then you will be getting conjugate base. So this is your an acid. If you are going to remove H plus, it becomes HPO4 minus 2, and hence the answer is D. If you want to get conjugate acid, that means you need to give it H plus. If you want to get conjugate base, you need to remove H plus. Is that clear, everyone?
yes, sir.
So how's your preparation sense? Only 3 to 4 days left. I will recommend you to do revision as much as you can the formula based chapter, and I will give you some important chapter that you should take care of, and definitely from that chapters 3 to 4 questions can be asked. And these chapters generally students lead: polymers, biomolecules, chemistry in everyday life, and environmental chemistry. These last 2 chapters you can easily study by yourself, and this chapter initially, if you will see, it has been studied by you in class 9, 10th geography, some part. Okay, and you know this chapter has been taught to you, and these 2 chapters you can study it by yourself in from NCERT. And the questions from this chapter is not tough. Only you need to study and keep some points in the minds, and that will be very good for you. In polymers, you have to remember the name of the monomer and polymer. That is very important. At my time of JEE Mains, the dacron was there in my paper. So you can say it's for free. If you are going to cover this chapter in this year, I hope 3 to 4 questions come, and that question is not like you cannot say it is tough, and neither you can say it is easy, because these are some theoretical questions, especially this and this. There can be a chemical reaction from this, but in this chapter polymers, the chemical reaction is quite